Project Summary. Our goal was to create a wireless remote-controlled car that was able to perform basic functions, which included going forwards, reversing, and turning left and right. Additionally, we added a pre-assembled robotic arm that was checked out from the lab. We attached this arm to the car's base with the end goal in mind for the user to be able to pick up small items with the arm. The arm had basic functionality and was able to swivel on its base as well as move up and down. Our wireless controller consisted of 2 joysticks connected to an Arduino and an XP. The XP connected to the Arduino acted as a transmitter for joystick values, while the receiving XP on board the car was connected to the embed. Setting up the wireless transmitter and receiver. The XPs had to be plugged into a PC and configured using a SparkFun USB XP adapter and the XCTU software from Digi International. The XPs are RF transceiver and receiver modules and therefore have to be configured to the same channel and have the same ID in order to broadcast and receive serial data. The Arduino was programmed to send out the data to the XP using the function serial.write. Onboard robot controls. The 2 DC motors in charge of moving the car forwards, backwards, and turning were driven by a dual H bridge whose inputs were connected to the embed. The functions included in the embed motor.h library were used to control the speed as well as turning. The servo-driven robotic arm on board the car utilized the servo.h embed libraries. Here's a photo of our completed wireless controller. As you can see, we have 2 joysticks and 2 push buttons connected to the Arduino. The user controls these to open and close the claw, swivel and bend the arm, and navigate the car forwards, backwards, and turn. The XP connected to the Arduino receives the serial data from the Arduino and broadcasts it on the channel to the XP on the car. Here are photos of our completed RC car. Note that we removed the claw attachments for reasons we'll discuss on the next slide. The photo to the right displays the board that is on the car. The board houses the dual H bridge used for controlling the motors, the pin outputs for controlling the arm servos, and the XP that receives the data from the wireless controller. In all, the build worked out the way we had planned and expected. We did have an issue with the servo and the robot arm that was responsible for claw grip. We were able to replace the servo, but the spare servo didn't fit within the claw and resulted in the grip strength being more or less useless when attempting to pick up items. As a result, our demo video displays the robot navigating and popping a balloon with a needle attached to the arm, instead of the previously planned demo of it picking up an object. However, we still included a clip in our demo video of the claw opening and closing to demonstrate our original design before we removed the claw and replaced it with the needle for the final demo. An idea for further work would be the addition of obstacle avoidance protocol. This protocol would override the user controls when a sonar sensor detects an obstacle within a critical range. It would return the control to the user once the robot had navigated itself away from the obstacle. This would be necessary for the robot's self-preservation and to make up for any human error that could result in the robot being damaged. Another idea for further work would be adding a safety protocol for when the wireless controller disconnects from the robot. In this case, an interrupt routine would shut down the motors and send a broadcast on the channel and await an ACK. It would return control to the user once the XP on board has received an ACK from the controller's XP. This would be necessary if the controller ends up out of range, has died because of lack of battery, or if the channel is experiencing too much noise from surrounding devices.